Welcome to a video on advanced traits and types in Rust. So now Rust type system and trait system offers powerful tools to define common interfaces for multiple types and to extend the functionality of existing types. Now this video delves into more advanced aspects of traits and types, including the associated type, default type parameters, specialization, and some more we'll cover. So let's jump directly into the first one, which is associated types. Now, associated types connect a type placeholder with a trait such that the trait method definitions can use these placeholder types in their signatures. There are a, there they are a way of defining a trait that uses one or more types without specifying what those types are until the trait is implemented. Now let's look at the iterator trait. If I want to, let's say, the way I do it is, I'll say pub trait iterator, and it's of, I have type item inside it and function next. So since I want to iterate through, I'm gonna create this next function, and inside that I'll pass the mutable copy of self, and I say option with self item. So this is how you can iterate over items using the iterator trait. Now in this example, item is an associated type for associated type of the iterator trait. Now implementers of this trait will specify what type item is for their particular situation. Now let's look at the default generic type parameters and operator overloading. Now Rust allows you to define default types for generic type parameters in traits. This feature can be combined with operator overloading to extend the functionality of Rust operators to work with your custom types. Now example of operator overloading with the add trait is here. Let's go for it. I'm gonna say standard operate. Okay, I think I forgot this one, and I'll say add is what I want, and I'm gonna go ahead and let's go inside the, let's go here, and I'm gonna create a struct, and inside I call it, the name is point. X is, I have two parameters inside I32, and y of I32. So I have two parameters for this struct. Looks good here. Next, I'm going to implement the add trait. Say add for point. I'm going to say type output equal to point. Then I'm going to add a function inside here. Say add, pass argument self and other, which is a point, and this returns back a point to me, and that point will be having x self dot x, the other, plus other dot x comma. Same thing for y. I'm going to say y is self dot y, and whatever the y of this other is, there you go. So that's probably the thing. And now inside here, let me get rid of this, assert equal to, let's check it out. I'll say point x, which is 1, and y, which is 0, plus point x, which is 2, y, which is, let's say, 3, comma, is this. If I add this up, will this give me point x? If I look at it, 1 plus 2, 3, comma, 3 plus 0, 3. So that's how we can specify an operator overloading with add trait. Let's run it, and we have an error, of course. Oh yeah, I have to specify, use this as partial equation. So run it, and there you go. It said everything is fine. It didn't give any error, or else it would have given an error if this was not matching. So that's how this works. Now let's next look at specialization. Now specialization is a feature that allows for more specific trait implementation to override more general ones. As of my knowledge, full specialization is not yet stabilized in Rust, but it's a feature that has been desired for allowing more flexible trait implementations. Now next we can look at trait bounds on larger structures. You can also use trait bounds to specify that a generic type implements a particular trait on structs or enums. Let's look at using a trait using a trait bounds. So first I'll say use the standard module with format with display. I get it right? Nope. Okay, once I have that, I'm gonna create a struct of, I don't need this time, pair, and inside that I'll add t, and the value is x of t comma and y of t comma. So I create a pair struct here. Now the implementation of this using t display plus partial odd, and I pass the pair structure here, and inside this I can implement the function cmp display and pass a pointer to self, or pass the address location of self. If self.x is greater than or equal to, let's say, self.y, I'm going to say print the largest member is x. If not, I can just say the largest member is y. So this is how you can use like trait bounds to specify use like you can use this trait bounds here to specify that a generic type implements a particular trait or for structures and enums. So this is how it works. Next we can look at the type aliases. Now type aliases allow you to create a new name for an existing type. This can be useful for reducing repetition or when working with complex types. Let's look at a very simple type for now. What I can do is I can say type, I can just define one, say let's say kilometers equal to I32. Now kilometers can be in I32, but when I'm creating a parameter of a value, let's say 10, I can just say instead of I32, I can say it's type kilometers. Now X is an I32, but the type alias makes its purpose more clear, so you know what it will have, the value it will have, even though it's I32. Next, the never type. The never type, which is the exclamation mark, is a type that represents the absence of any value and is used in functions that never return. Example, like we looked at panic, we looked at println, it has this exclamation mark at the end. We have panic, which has this exclamation mark. So this is kind of represent that the absence of any value and is used in functions like this. Next is dynamically sized types, which is also called DSTs, and size trait. DSTs are type whose size is not known at compile time, so you don't know the value of those. That's why it's called dynamic sized, of course. The most common DST is str, as we mentioned earlier. Like you have a string and you say hello, but you can keep on appending more value to it. Now, to handle DSTs, Rust uses size traits to determine whether a type's size is known at compile time. By default, generic functions assume types are sized, but you can't opt out. You can opt out with something called as question mark size. So, for example, I can say generic and I want it to be not sized, so I can just say question mark sized here this way, and inside this I'll pass the rest of the stuff, and you can enter your code here, and this is how you can have the dynamically sized traits for generic styles. Now, advanced traits and types in Rust provide a robust framework for building reusable, safe, and efficient code. By leveraging all the features that we've learned, like associated types, default generic type parameters, trait bounds, type aliases, and others, you can write expressive and powerful Rust code that abstracts over details where necessary, while still being explicit and type safe. So, if you have any questions on this, leave me comments and I'll get back to you. Thank you.